Our environmental engineering design team will present our proposal to grow oyster mushrooms from non-recyclable paper waste. To better understand why we will be using paper waste as a growing substrate, Leandro will preface our design with information about the pulp and paper industry.
The pulp and paper industry is one of the largest in the world. It is dominated by the North American market as it is used throughout the continent for everything. Due to the ever-increasing electronic capabilities, the use of paper has decreased by 24% from 2006 to 2009. Although, North Americans are still responsible for 60 to 265 kilograms of paper per person per year. As the far majority of North Americans have access to frequent roadside recycling, the recovery rate of paper products is over 63.5%. And at the same time, the percentage of recycled paper increases each year. But pulp and paper recycling plants can become more efficient, as 15% of non-hazardous material is discarded as a sludge byproduct. This byproduct is commonly landfilled, as it seems to have no purpose. But someone's trash is always someone else's treasure. A method of manufacturing solid fuel utilizing paper sludge along with coffee sludge was designed by a South Korean team to mitigate the recycled waste. The contrasting properties of the sludges creates a solid fuel with a standard combined heating value into a viable fuel for combustion. It may seem hypocritical to turn the sludge, which would either be landfilled or incinerated, into a fuel source that will eventually be combusted, although these fuel pellets will be used as a means to transfer energy.
Converting sludge into a fuel source is a viable option in areas close to recycling facilities. However, for many remote areas in Canada, sending recycling to a facility is not economically feasible, and recycling is sent to landfills instead. Additionally, in remote northern communities where the growing season is short, food insecurity is alarmingly high. We propose a solution to both these issues by growing oyster mushrooms on paper waste. This allows for the conversion of a waste product to a highly nutritious food source year-round. Oyster mushrooms grow very well on lignocellulosic materials and are high in protein, vitamin C, and potassium. Cultivation is relatively simple, with the only growing materials required being paper waste as a substrate and oyster mushroom grain spawn. If the following cultivation steps are followed, it can take as little as 3 weeks from the start of the process to the first harvest of mushrooms. When paper recycling arrives at the recycling facility, it will be chopped into small pieces around 1 to 2 inches long, then pasteurized in hot water for 1 hour. This step removes any possible contaminants such as competing fungi or bacteria, which may disrupt mushroom growth. After pasteurization, the paper will be inoculated with grain spawn and placed on large trays. These trays will then be placed on racks in the growing room, where proper environmental conditions will allow for colonization to begin. After 2 to 3 weeks, the substrate will be fully colonized with the mushroom mycelium, and environmental conditions in the growing room will be changed to initiate primordia formation by decreasing the temperature and increasing light, humidity, and airflow. After 3 to 5 days, humidity will be decreased and temperature will be increased to initiate fruiting, and 4 to 7 days later, the first flush of fruits can be harvested. After 7 to 14 days, the cycle will repeat and another flush of mushrooms can be harvested, with a total of 3 to 4 harvests. After harvesting the mushrooms, they can be packaged and distributed, and the leftover substrate can be saved for reuse as a soil additive or simply composted.
As we just saw, the process for growing oyster mushrooms from a waste paper substrate is very simple and low maintenance. So much so, Liesl was able to grow them in her own home over a span of a few weeks. When looking at a larger scale production, the simplicity of the system allows for affordable infrastructure. Any building can be converted for this 7-step process. The small learning curve means the facility can be run and managed by local communities, making it ideal for remote regions. Drawbacks to the design is the energy consumption. Even though the mushroom can grow at moderate temperatures, the main concern is the pasteurization of the waste paper substrate. Boiling water for an hour becomes very expensive with a large production facility, even more so for remote communities that need to fly in fossil fuels as their primary energy source. Even with its drawbacks, growing oyster mushrooms in remote communities in Canada reduces the amount of paper in our landfills and creates a much-needed local year-round food source.